Okay, so a few years ago I bought myself one of these off eBay, a Farnell ET30/2. It's a fully regulated dual power supply. It can output DC volts up to 30 volts at 1 amp or 15 volts at 2 amps. So when I got it, I had these two analog needle gauges that can become voltmeters or ammeters. Now I don't have much faith in them. I have always, when I had the screens, the dials on, I would always hook up a multimeter to the output because I could never trust them, and I didn't know which, without the multimeter to test it, I could never tell when you flick the ammeter voltmeter switch which way it was because there's no markings to tell you. So the first thing I did when I got it was I swapped out one of the dials for just a digital meter and just hooked it to the output, and as you can see on that bit of cardboard there, I just attached it over the top as a temporary thing, intending to properly fit it later. Well, years later I still hadn't done it, and I use it quite a lot when I'm doing testing and fixing stuff. And one day the digital screen stopped working. I thought I burnt it out because I was doing something stupid with the power supply, so never used it again. I just used the right hand side power supply and that was fine. But I recently was waiting on some parts coming from my 3D printer, and I was ordering stuff anyway, and I saw some screens that have a voltmeter and ammeter, so I thought I'm gonna upgrade this and put two digital screens on both sides. So I had some scrap aluminium from my 3D printer, so I thought I am going to use a scrap bit of aluminium to mount them to. I'll reuse some of the existing mounting points. Now at the moment in the video, what you've seen so far is I've got the bit of metal, I've clamped it on, measured the position of the original holes, and I'm using a drill tap. So it's like a drill bit with screw tap threads on it. So as you drill it, it actually taps the hole for, well, M4 is what I've used. So that's what I'm doing here. I'm just drilling all the holes. Now I didn't use them all because, to be honest, it was pretty solid with two fixings, but I put about 3 or 4 in when I finish it, and it's totally adequate. It's not a perfect size bit of metal, it was just a scrap bit of metal I had, so you can still kind of see through the holes, but it's enough to stop you sticking your fingers anywhere that you could electrocute yourself, which is totally fine. And it's a lot more solid than what I had. Now what I'm doing here is I'm using this crappy Ryobi grinder with a 1.3 amp hour battery, and it is absolute garbage. I wish I'd known that my dad had his DeWalt grinder in the van, because that made the cutting aluminium so much easier. I was here for ages cutting this, and it just keeps cutting out that grinder. It's just crap. I think the batteries are stuffed. But anyway, eventually I did manage to do it. I used that until the battery ran flat. I tried using a file. I also used a Dremel type tool to cut through it. It did mean, because I had so much issues with the grinder cutting out, my holes are slightly oversized, so the screens don't fit perfectly. They are good enough that they hold themselves in, but they do wobble a bit if you touch them, but you shouldn't really be touching them, so it's fine. Yeah, so yeah, I spent quite a while. Now this is sped up 745%, so you can see how long I was at it, which is, yeah. So after quite a while of doing this, I was getting pretty tired of doing this, so I had a look around, and I realised that there was actually a rotary tool sitting in a box. So the first thing I did was I tried a rotary file bit in it, which was completely useless. It didn't make any work, it didn't make any effort at cutting it. So I then realised that I had these black disc cutter things. I'm not sure what they're made of. It's like something that wears really quickly. I went through about 3 or 4 of them, but they did cut much better than what I'd been doing up until that point, so they were quite good. The observant among you may have noticed there's a bit of a reflection going on. That is because I'm doing this in the workshop area of a shop that's open to the public, and I keep getting called through, and because of pandemic precautions, I'm wearing a face visor, and so every time I go out into the customer areas I put it on, and when I come back here I try to remember to take it off so that you get a clear image, but I sometimes forget. So that's what the reflection's about. So here I am still working on the holes. I'm test fitting the screens as I work to make sure that they fit. They were a little bit loose after I finished it all. It was hard to do with that Ryobi because it kept cutting out, and yeah, I would get halfway through a cut and it would stall. Now I put a bit of a brushed pattern onto it where it's going to be visible. I sort of put them at opposite angles for each screen just to make it look a bit different. It looks better than it did when it had various marks on it, so it's better than it was. Now the screens themselves I bought off Amazon. It was a 2-pack. They were like under 10 quid. They're not probably as precision as you could get. I just wanted something with a digital screen. Accuracy was not mad critical for what I use it for. You'll see that I've had to use some tape on one of them just to make it fit. The hole was a little bit too big. One of them was near perfect. It was just a little bit loose. The other was well too loose. It would probably not have fallen out, but I wouldn't have been happy with it wobbling as much as it did. So that's what it's going to look like. Now I don't fit that plate in properly until I'm finished, but it was just so I could move it about whilst I'm testing it. Now I'm quickly going to tidy up so I have some room to work. Now one thing I will say before I get to the soldering point: underneath each of these PCBs there are these huge capacitors. Now I did test them with the multimeter off camera before I started and they were discharged, but just watch yourself. If you do happen to touch them, you could give yourself a pretty nasty shock if they're fully charged, because they are huge. I didn't actually test what capacity they were, but they're pretty massive, so I'd imagine that they're pretty big voltage ones. So what I did here was I had a quick look at the board to see how I was going to wire it. So each board here is the power supply, so they're like two separate power supplies. You can see the transformers in the background. On the right hand side of each power supply there are 2 binding posts, and these binding posts directly connect to the banana plug outputs on the front. Now these binding posts are where we're going to get our power and our measuring for the meters from. So the meters that I bought have 2 different plugs. There's 2 reds and 2 blacks. There's a thick red and black and a thin red and black, and also a thin yellow. Now the thin wires are your voltmeter. Now you don't need to connect the thin black because the thick black and the thin black are common. They're linked together internally. So when you connect the ammeter up, you'll be providing the ground plane for the screen. The red and yellow, you have to common them up, and they get soldered directly to the positive binding post. The ammeter, what you have to do is you'll have to desolder the existing black wire basically from that binding post. You'll attach the black wire from the thick black wire from the ammeter. That will go onto the binding post, and then you'll need to use some heat shrink and join the thick red wire to the black wire from the original wire on the front post. Once you do that, the meters do work together. They work fine. Now, when I was wiring this, did the left side first, and I couldn't get it working. And that was because I had assumed that I'd just blown up the original voltmeter display, but it turns out it was actually that left-hand power supply. It was not working. I do fix it later on in this video, but that is why I spent a while trying to figure out what was going on, before I eventually just swapped over and went and started on the right hand side, which I'd been using up until that point for when I've been using this power supply. But I'd assumed that there was something causing that. I thought that voltmeter was dragging the thing down to ground, like had some kind of open fault on it, but it wasn't. It was in fact caused by this transistor, which had apparently failed, probably when I blew it up. So I went on to eBay and I got 5 of these, or no, 4 of these for about £5, which is pretty cheap, so I've got plenty of spares. Apparently it is a very common part to fail. You'll probably see at some point in this video, I was googling it on my phone to figure out what was wrong, because I had a sniff of the board. There was no obvious burnt smells, there were no obvious blown components. I was thinking that there would probably be a fuse, but there wasn't, and I saw the transistor and I thought, you know, it's probably going to be that, but I would have to take it off the board to test it properly. So I went and had a quick Google, and in the forums pretty much everyone was saying this part blows all the time. It can be blown by inductive loads and a few other things. So I thought, you know what, for £5 I will give it a go. So I got the parts later after I've built this up. I come back and I sort it later in the video, and as soon as I swapped it, it worked. So that is the solution. This was me testing. I was concerned that the screen had that I damaged the screen off that power supply at first. I thought there was maybe some kind of weird voltage issue or something like that, so I tested both screens, but it is working. So yeah. Now you probably couldn't see on the screen because of where my head cam was. I've actually got the multimeter and the original analog meter screen attached to the output. The reason I've done that is I was thinking about it, and the current meter was still displaying 0, and I was thinking, this is not set up, this is not wired correctly. Well, it was, but there was nothing connected to the output, so there was no load on it for it to actually detect and measure. So I put the little analog meter onto it, and then had something to display. That's why it was there saying 0.11 amps. Now, in case you're wondering what I'm doing here, at this point I was just trying to test a few different components. I wanted to check that capacitor had charge in it or not, and then I thought I'm going to quickly test some of the components, and then I was like, there's no point. I'm pretty confident it was that transistor, so I just stopped. I decided if it wasn't that, I would then do a full check of everything, but it didn't need to, as it turns out. So it was at this point I'd figured out the wiring for each of the meters, and it was at this point that I decided I would quickly investigate and see if there was common faults. And it's at this point that I found the articles telling me about the transistor, and at the time I was thinking I could maybe test it in situ. So I was looking up the charts for like the diagram for the component to see if I could find out the information about the voltages and stuff. And then I thought, you know what, I'm gonna get them in because they're so cheap, and I'll just swap it and see if it works, rather than faff about with that, because it's not an easy place to get to with the test probes and stuff like that when it's plugged in. But that's just a data sheet for that component. One of the things I did notice when I had the casing open was that the boards were covered in a thick layer of dust, and I don't know if it was like an oily residue or something. It's probably just from however many decades old the thing is, it's just built up over time. So I gave it a quick brush off before I reassembled it. I got the worst of it off. I was just concerned if any of the dust became conductive, it could cause problems down the line, so I got the worst of it off, and that was fine. Now, on the day that I filmed the first bit of this, I obviously didn't have the new transistors, so I decided after I'd sort of got the thing tested and working to a certain extent, I decided that I would just put it all back together so that there wasn't anything lying about and getting lost, and I'd come back to it later, which I do later on, just in a few minutes you'll see it. But I put it all back together. It looks great. I'm really happy with how it's turned out at this point. Obviously at this point only one side of the power supply is working, but it has the sort of desired look, and the performance of this thing is great. It's got two independent transformers and two regulated power supplies. It's fantastic. It is pretty heavy because it's got two transformers in it, but it's pretty good. And I didn't pay anywhere near what these are selling for online now. I think I paid about 30 or 40 quid for mine, and they're selling, I mean, I don't know what year these things are from, but based on the weight and the look of it, I would suspect it's probably from the 80s, and they're now on sale for sort of 80-90 quid. Now, what you just saw there was I grabbed the old multimeter because I'd thrown it in the bin, well, the screen, and I just tested it there, and you saw it was actually working. Now I'm just this is the point here where I've pulled it all to bits before I started the video again. I've just gotten the delivery of the transistors. Now I'm desoldering the old one. Now I don't know what these circuit boards are made of, but the tracks seem to be lifting off the board when I got the thing off. Now I've done what I can to push the tracks back down. And I've used the legs of it and the solder to sort of force the tracks to stay stuck down, but I don't know if it's just that it's like a plastic with a metal lamination on it, or what. It doesn't look like a regular PCB, so I'm not sure if it's just some old style thing. It's not your traditional thing with solder mask and copper. I'm not sure what they are. It's old fashioned. It actually, you'll probably see it in that picture there, the back of each of the boards has like this almost like a PC ISA card slot that pushes into a socket on the back, and that's what powers each power supply up. It's like they're like each card, which is a bit, yeah. Now the first thing I did when I powered it up, it didn't come on until I touched the dials, because it was turned right down to 0, well, not 0 volts, but really low, below the minimum voltage for these screens. That is the only potential downside. If you're going to run it at less than about 3.4 volts, they're probably not going to be any use for you. That's the switch on voltage for the screens. But I don't really tend to run it at that kind of low voltage. Most of my time it's 5 volts or higher, so 5 or 12 is what I tend to use, sometimes 9, but usually in that range. I've never used it. It can output 30 volts. You will see that I do test it. It does output those voltages, but I've never found a use for something at that voltage level.